Justina. As Justina pointed out, this is not my first visit. I was here 17 years ago for the introduction of this center. This building did not exist then. I was the keynote at the kickoff event. Anyway, it's a pleasure to be back. I thought I'd start this talk by telling you something that happened to me about 2 years ago. I was boarding a flight to Buenos Aires to give a talk at the University of Buenos Aires and in New York. And as I sat down in the airplane, I found myself next to a young woman who had just obtained her degree from the University of Chicago. We started chatting, and it turns out that she was working for a cloud-based education company. I just started my own cloud-based education company, Learning Catalytics. You may have heard about it. So I thought, I better find out what she's doing. So we started talking, and it turns out that her company was making flashcards for smartphones. I had trouble not rolling my eyes, because those of you who followed my career know that I don't place much value on memorization. Well, it turns out I had just attended a talk by a psychologist from Washington University by the name of Ruddy Rödinger, who studies memory. And one of the things he studies is how much is retained from studying with flashcards. In fact, in Science in 2010, he published a paper showing that if you study with flashcard and you test the retention, you find reasonable retention after 1 or 2 days, but after just 1 week, only 35% is retained. After 2 weeks, you can't even measure it anymore. I thought she should know about this. Turns out, I downloaded the article on my iPad, so I bent down, I grabbed my iPad, pulled up the article, and gave her my iPad. She took the iPad, she looked at it for no more than 10 seconds, and then handed me back my iPad. And she said, but we only guarantee that they will pass the test. I'd never thought about it this way. And it brought back all kinds of memories. My daughter was an undergraduate at Harvard. And my daughter and I spoke often about education and about approaches to studying. On the weekends, she'd come home in the passenger seat on my right. Flashcards. Natalie, what are you doing with flashcards? She'd say, well, I have to know all these amino acids. I'd tell her, I have an app for that on my phone. She says, yes, but we cannot use the app during our exams. So that made me realize that the study habits of students are determined by the assessment. And I'd put all of this energy for years, for decades, into changing the approach to teaching without really thinking about the approach to assessment. And if that, passing the test, is the only thing that matters, then we should have paid much closer attention to what this man said many decades ago. You may recognize him from Saturday Night Live, Father Guido Sarducci. In the 70s, 40 years ago, he came up with a brilliant proposal for a 5-minute university. How many of you are familiar with that video clip? Oh, not many hands go up. Google 5-minute university, and you'll, not now, please. And you'll be in for a good laugh. It's hilarious. The premise is this. Just take 5 minutes to teach what the average college graduate remembers 5 years after coming out of college. Right? Like Spanish, for example. The only thing you need to know is the following. ¿Cómo está usted? How are you? And the answer is, muy bien. Anyway, go and watch that. So, those of you who have followed my career know that for more than 20 years I've been bashing the lecture as an outmoded approach to teaching. I was at University of Washington yesterday. I don't know how many of you saw the paper by Scott Freeman that was just published, which is a meta-analysis of many, many studies comparing the lecture to active engagement, showing really stunning data on how active engagement increases the grades and reduces the failure rates. I was interviewed by Science Magazine, and I stated, that if you know those data, if you see those data, it is unethical to continue to lecture. Well, here I am lecturing to you, but I'm not using this to teach you anything. I'm here to. So anyway, why is the lecture, in my opinion, an outmoded approach to teaching? Because it focuses on information transfer, and education is so much more than education transfer. Today, I'm going to argue that the assessment practices that we use are equally problematic, because most of them are focused on the regurgitation of memorized information and cookbook procedures, and do not really teach authentic skills. And therefore, instead of developing the 21st century skills that we really want to instill on our students, our assessment practices are mostly focused on ranking and classifying. So here's what I'd like to do with you in the next 40 or 50 minutes. I'd like to talk first a little bit about assessment. I want you to reflect on the purpose of assessment. Why are we assessing? Secondly, I'd like to discuss some problems that I've identified with assessment. And lastly, I'd like to offer a few concrete ideas for improvement. But keep that initial anecdote in mind as we go through this. Okay, so let's start with reflecting on the purpose of assessment. I want you to, if you sit next to somebody you don't know, to introduce yourself, and I want you to take a few minutes to write down as many purposes of assessment as you can think of. Okay, so go ahead, talk to each other, and make up a list. Is that Andrew Bordeaux there?
Yes, it is.
Yeah, I'm going to say hi to him. Hey, Andrew.
Hello, good to see you. Welcome to Western.
I was delighted to hear that you were here. So,
thanks for coming. It's great.
So will we have some time later on?
I would love to spend some time together if you have.
Yeah, I don't think I have anything after 4. So, yeah, good.
Delightful.
Hi.
Yeah.
Okay, great. Okay, how many of you have made a list of more than 5? Let's see a show of hands. Oh yeah, I need to give you a little bit more time. So one and a half more minute. Okay, so let's see what we got. Let's hear it. Give me a few reasons for assessment. Who's? Shout it out, yes. Motivating the students. Generate the grades. For what are the grades good for?
Justify the existence of our program.
That's one I haven't heard very often. Justify. Certify knowledge.
Feedback to instructors.
Feedback to the instructors. To inform what you as an instructor do next. Do we have some students here who could also shed light on? Yes. Whether or not you study, okay. Anybody else? Yes.
Integration and synthesis can be a vehicle for that.
So from the student's point of view, integration and synthesis. So find out preconceptions, okay?
How will they understand the material? Pretty basic.
So whether the material is understood, did I? Okay. To whom? To the student, okay. Feedback to the student. Okay. Any students here who want to comment on how they perceive the, yes?
What's important to the teacher?
What is important?
To the teacher.
To the teacher. Kind of late to find it out on the assessment, right? But I agree that that's what happens from time to time. Any other student who wants to speak up and give his or her perspective? Yes? To determine whether or not you can do it on your own. Very good. Critical thinking skills. Here is a list that I put together, and I don't think I would really order things in that way, but one is to rate and rank students, absolutely, and in terms of their peers. To rate the professor and the course, again, absolutely, and in the eyes of the department. To motivate, to provide feedback on the learning to the students. I think we heard all of those before. To provide feedback to the instructors on meeting the student needs and the needs of the department. To provide some kind of an accountability. And I heard the word certification before. I guess that would fall under that heading. And to improve the teaching and learning, to find out whether we're doing the right thing in front of the class. There's one reason you all missed, which is so that we instructors can fly off to conferences. And I'm sure that many faculty assign midterms at dates that they can't teach. I certainly think I'm guilty of occasionally doing that. Notice that the verbs that are on there are sometimes contradicting, right? I mean, all of these reasons are not all in alignment with each other. So let's, now that we've established this, turn to the problems. I already made the point that much assessment is inauthentic because it basically teaches factual and procedural knowledge, never getting to the 21st century skills like critical thinking that we talked about it. But I'd like to go even one step further. I'd like to say that many assessments that claim to actually test problem solving do not do so. And let me explain why. What is a real problem? When you have a real problem, you generally know what the desired outcome is. You know where you want to get. Let me give you an example. You have a job interview in New York. You head out to the airport. 1 o'clock, the last flight to the East Coast. Your flight is canceled. The interview is tomorrow. You've got a problem. The outcome is known to be in New York on time for your interview. The question is, how do you get there? You're a hedge fund manager. The desired outcome is to make investments in such a way as to get more money. Outcome is known. How do you do that? You're the CEO of a company. You need to make a product successful. I mean, all real-world problems fall in that category, that you have a known or desired outcome, but the hard part is the solution and finding this unknown solution to get to a known outcome. Most textbook problems do not fall in that category. You have a problem, and then students are asked to apply a known procedure to find an unknown answer, right? Let's say something from my own discipline, physics. A car is going along a road, blah, blah, blah. It hits a tree. What is the velocity of the car just before it hits the tree? The student in his or her mind thinks, well, what are the equations that permit me to calculate a velocity? And there might be a handful of them, and you eliminate those that don't have the unknowns that are given in the knowns that are given in the problem. So you just work by elimination, and you apply this procedure for calculating the velocity to find 4.2 meters per second. And it's the answer that matters, not the procedure. So let me put this in a slightly different light. Let's think about Bloom's taxonomy. Bloom was an educational psychologist in the 50s who sort of ranked thinking skills from lower order thinking skills at the bottom of this pyramid to higher order thinking skills at the top. Things like remembering, and remembering mostly factual information at the bottom, to understanding, being able to apply what you've learned in a given context, to applying it in a new context. I would say that most of what happens in education, including higher education, stops somewhere. Maybe the humanities are ahead, but in the sciences, stops at the applying level. In fact, most students are not able to apply what they've learned in a new context. Not that long ago, I was giving a talk in the physics department at a school in Connecticut, south of Boston. Good school, I won't name any names. And after my talk, one of the physics faculty came to me and said, I had something really interesting happen in my class this year. He was teaching physics for engineers, and he wanted to make his course relevant to his students. So what he did, he put it into a real-world context, and the real-world context that he chose was baseball. I mean, there's a lot of physics in baseball, right? The trajectories of balls, collisions between balls and bats, runners running. So in class, he would use examples from baseball. On the homework, he would put baseball problems. On the midterm examination, there'd be baseball problems. At the end of the semester, he was writing his final exam, and he realized he had run out of baseball problems. So he put some football problems on the exam. Professor complained to students, we've never done any football problems. You're laughing about it. But we should really be crying, right? Because unless you're able to apply Bloom's taxonomy level 3, what you've learned into a new context, you have not really learned. Okay, so let's, to put this in context, take a problem that I think goes all the way up to the more authentic problem-solving skills at the top, and deconstruct the example and turn it into a standard textbook problem. Enrico Fermi, who was a Nobel Prize-winning Italian physicist who was on the faculty at the University of Chicago, became known for starting his classes by asking students estimation problems, like how many piano tuners are there in Chicago? Well, you can guess, but you can also try to estimate it by, asking yourself how many people live in Chicago, what fraction is pianos, how many pianos can a piano tuner tune, and so forth. And in the process of doing that, you get much more confidence in your estimate, and you learn really important skills that have to deal with orders of magnitudes and making assumptions and so on. Those problems, by the way, are now often known as Fermi problems. Well, I'm a physicist, and I wonder some of these things constantly myself. Not that long ago, I was painting my dining room, and on a Saturday morning, I ran out of paint, so I had to go to the hardware store to buy some paint. So I hopped into my car, I drove to Harvard Square, and at Harvard Square, there's this hotel called the Harvard Square Hotel that is actually elevated, and underneath at street level, there are public parking spots, 20 on one side, 20 on the other. So typically, I come in from the street and then pull into one half, and then if there's no spaces, I pull out on the other side in the street and then go back and go around and around and around until finally somebody frees up a spot. But more often than not, I'm on the left side, and then I see, oh, there's somebody leaving on the right. You pull out in the street, you have to go back, and then another car takes that spot. That Saturday morning, I don't know for what reason, I said to myself, you know what, I'm going to just give up on the other 20 spots. I'm going to turn off the engine and wait. And I turned off the engine, And I immediately started wondering, how long is it going to take before somebody comes back? I thought about it for 30 seconds and came up with 3 minutes, looked at my watch. Sure enough, 3 minutes later, somebody came and freed up a spot. I felt so good that I'd been able to estimate that. Now imagine we put that problem on a test. On a Saturday afternoon, you pull into a parking lot with unmetered spaces near a shopping area. You circle around, but there are no empty spots. You decide to wait at one end of the lot where you can see and command about 20 spaces. How long do you have to wait before somebody frees up a space? I bet you, if you put this on the exam, your students are going to go to the dean and try to get you fired. What are the type of skills you need in order to solve this problem? Well, you need to make assumptions. You need to develop a model. There's no cookbook procedure for this. And then you need to apply that model. In terms of Bloom's taxonomy, we go all the way to the top here, from applying knowledge to being creative. What is of the skills that are required that are listed on the left of on the bottom left of the screen, what is the one that the students hate the most? Assumptions. Have you ever tried to put a problem on an exam where you did not specify everything exactly? I mean, in my context, again, physics, let's say there's a problem and, I've forgotten to specify whether or not students can ignore friction, even if it's completely clear from the context whether or not it's important. Within seconds, students raise their hand. Are we assumed in this problem to ignore friction? They want you to take the responsibility for the assumption. But think about it. Making assumptions is probably one of the most important skills. And the discomfort with assumptions, we'll get back to that later, I think in part is due to the fact that we never train students in making assumptions. We never give them an opportunity to make the assumptions. So let's take the assumption out, by basically putting in there, on average, people shop for about 2 hours, right? 2 minutes is too short, 2 days is too long, so 2 hours is probably in the right ballpark. I mean, we've gone down a tiny little notch, but I would say we're still pretty high on Bloom's taxonomy because they need to develop a model on how to solve that problem. And still, students will be furious. I mean, you're testing them on something you've never taught them. So let's put the model in there. We add the sentence, assuming people leave at regularly spaced intervals. How long do you have to wait before somebody frees up a space? Now all of a sudden we're dropped all the way to the applying level, right? There's the analyzing, evaluating, creating is all out of there. And still, students are going to be furious at you. I mean, they've never done any parking lot problem, so why? So let's now turn it into a standard textbook problem. Here we go. On a Saturday afternoon, you pull into a parking lot with unmetered spaces near a shopping area where people are known to shop on average for 2 hours. You circle around, but there are no empty spots. You decide to wait at one end of the lot where you can see and command about 20 spaces. How long do you have to wait before somebody frees up a space? You say, wait a minute. Isn't that the problem that we started with? Yes, but somewhere in the book, there's this equation colloquially known as the parking lot equation. And the students have memorized that equation, and the only thing they need to do is plug in the numbers that are given in the problem. And all of a sudden, we're all the way down at the bottom of Bloom's taxonomy. You're laughing about that. I think it's a sad truth, because a lot of what we do falls exactly into this category. And I think that's a problem, because if you look again as these two different types of problem, with the last one really fitting into that bottom category, we live in an age where computers can do that. And just as robots have replaced assembly line jobs, so do I predict that computers will make any job that involves memorization or the application of rote procedures unnecessary. So we should really focus on authentic problems. Now, authentic problems, in fact, anything that has to do with creativity or with innovation is by nature erratic. You try one approach to find the solution and it doesn't work. You try another and again it doesn't work. You try a third time and maybe it works. The light bulb, Thomas Edison, he just didn't build a light bulb, no. There were hundreds of failed prototypes before he finally succeeded in making a working prototype. So the road to anything innovative or creative is littered with failures. But the problem is that our assessment practices are incompatible with that. Students know that if they make a mistake, they lose points. So they become afraid of making mistakes. You have to create an environment where it's okay to make mistakes and to fail. And I would say that the message that our current assessment practices communicate to students is, every mistake is bad, you lose points. Mistakes are not opportunities to learn, no. They're failures. So, let me turn now to this picture, which needs no words. You saw probably within a second what this was. And if this picture evokes pleasant memories, then I would like to talk to you after my talk. When you look at this picture, what are some of the feelings that it evokes? Just go ahead, shout it out again. Anxiety. Stress. Stomach ache. Fear. Panic. Let's have some students here. Isolation. Fantastic. That's exactly. He's glancing at my slides, which he downloaded. So notice that everything we heard were negative adjectives, right? I mean, stress, anxiety, fear, stomachache. Is that conducive to learning? Is that how, young children learn? No. I mean, I think we're all born learners, hungry to learn, and unfortunately we lose that ownership of learning, in part, I think, because of our assessment practices and approaches to teaching. But you're right, the one thing that stands out from this picture is isolation. Everybody's isolated from each other and from any source of information. Ask yourself, after graduating college or finishing graduate school, did you ever encounter a situation such as the one on the screen, where you're not allowed to talk to anyone and where you're not allowed to look anything up? When I write a paper on nanophotonics, is there somebody standing next to me who, when I'm writing a paper, who says, you're not allowed to look up that paper by this professor at Yale, you should have known it by heart? I can look up whatever I want, whenever I want it. It's not about memorizing information. It's about how to apply the knowledge that we've developed as humans. And traditionally, I think assessment has been a high-stakes affair, culminating in the final exam. Students are told to study for exams. In fact, faculty usually encourage studying for exams. But we know what that does. That leads to cramming, and cramming leads to information just being stored in short-term memory, and therefore there is neither any retention nor any transfer. In a sense, the assessment is the silent killer of learning. Because no matter how innovative our approach to teaching, it is the assessment that drives student study habit, Why was my daughter studying from flashcard? Because she had to memorize it for the test. And, you know, if she weren't continuing in biology or chemistry, she would probably forget the amino acids. So it's just transient. You know, in fact, some of you may remember, in December, 20th of December, or no, the 15th of December last year, there was a bomb scare on the Harvard campus on the first day of the examinations. 4 buildings, 4 bombs. There was a student who didn't want to take exams, so he had called in bomb threat. I was actually in Hong Kong, and I happened to turn on the TV, and I saw my own campus there, and you know, the buildings being evacuated on the first day of the examinations. An hour later, I got an email from the dean, which was addressed to the entire academic community, students and faculty, saying that the dean had decided to cancel all the exams in those 4 buildings for that day and postpone them 2 days. And he realized that it was a problem for the students because they had studied for their exams. Wait a minute. Seriously, I'm quoting from that message. I still have the message here. I haven't called the dean out on this, but wait a minute. Postponing it 2 days is a problem because they studied and, you know, they won't retain the information 2 days later. Unfortunately, that is, you know, to some extent exactly what happened. Instead of studying for exams, students should study for learning. You say, well, isn't that the same thing? In an ideal world, it is. Unfortunately, in practice, it isn't. Now, assessment, in a sense, has 2 major purposes. One is to measure students' relative standing to others. The other one is, in a sense, an opportunity to improve the learning, to give feedback to the students. However, I would argue that most exams that we give in higher education and in high school, and maybe even in elementary school or middle school, that feedback falls through the cracks. Students take an exam, they hand it in, a week later or maybe 2 weeks later get their exam back, graded. The thing that they worry about the most is the grade. They don't use it as an opportunity to learn from their mistakes. Incidentally, in the UK, a study was done, a fairly large study in a number of schools, high schools, where they eliminated grades completely. There were still exams, but the focus was on the feedback, not on the ranking or the grades. And they found that students actually studied harder and learned more by looking at the mistakes they made and learning from the mistakes, rather than get hung up on this ranking that we place such an incredible value on. Then there's another thing. Assessment poses a conflict, which I call the judge-coach conflict. When I teach, I'm coaching my students. I'm now teaching in a very different space from this. I teach a team-based and project-based class. And my only role is to basically coach the students to make the best possible project they can make. So during the term, I'm constantly there coaching them. The first year that I taught that way, when it came to the project fair, all of a sudden I felt like making a Jekyll and Hyde transition from being the person helping them to being the person judging them. And it was actually very, very hard because I'd been so close to them, coaching them. I found it very difficult not to give them all A's because I knew how hard they'd worked on their projects. I mean, imagine you're coaching a figure skater, and then you go to the Olympics, and all of a sudden you say, well, go skate, I'm going to judge you. I mean, it would be unacceptable. But in a sense, we create that conflict in education because I think it's one of the few human enterprises where you get to judge your own work. So how do we get away with that? We get away with that by hiding behind a very thin veil of objectivity. We want to use something that does not involve emotions, that we can objectively assess. Unfortunately, the problem with that is that if you look at Bloom's taxonomy, the only thing that can be completely objectively assessed is memorization. or the answer. Take that question about, the tree hitting the cart that I was sort of alluding to earlier, and the answer is 4.2 meters per second. That you can assess objectively. If it's 4.2 without meters per second, it's wrong. If it's 2.1 meters per second, it's wrong. No feelings involved. But as you go up Bloom's taxonomy, that is no longer possible. So in a sense, because of this coach-judge conflict, we're forced to only look at objective measures, and therefore looking at metrics that are not very meaningful. So there are many other problems, like grade inflation and cheating. Why would a learner be cheating? Small children, when they learn how to tie their shoelaces or whatever, they're not cheating. Why would you cheat? You want to learn. Any learner driven by intrinsic motivation will never cheat. The only reason students cheat is because we create a system that permits them to cheat, to take shortcuts. So it's really our fault, not the student's fault. We've created the wrong incentives and wrong system. So let me end here in the last 15 minutes by suggesting a few possible improvements. The first one is, let's mimic real life. Let's have them use the information rather than cutting them off from information. Let's make all the exams open book. I didn't do that in one step. In fact, the first year that I thought, I don't want my students to memorize all these equations, so I'm going to give them a sheet of formulas. The next year, I gave the sheet of formulas early in the term so the students would know what was on the formula sheet. And some students said, well, I like your formula sheet, but I would prefer to have other formulas on it. Can I bring my own? Okay, everybody can bring one sheet, one side, 8 by 11. Then you discover, of course, that they can have this microscopic handwriting. The entire textbook is on one side of the page. So the next year I said, you know what, let them just bring the book. And then some students went, well, I don't quite like the book that you assigned. In high school I was using this other book, which I really liked. Would I be able to bring that book? Sure, bring any textbook you want. And then the following year, some students said, would it be okay if I brought in the solutions to the homework problems and my notes? Yes, you can bring anything you want except another living person. And then more recently, I started to assess my students using the computer. And now, all of a sudden, they have access to the internet and Google. At first I thought, is that going to be a problem? But then I convinced myself that it was not only not a problem, it was actually a huge bonus. It put a little bit more pressure on me, because now, all of a sudden, any question to which the answer can be Googled is no longer a valid question. And I would argue, probably, any question to which the answer can be Googled is simply not an authentic assessment. Right? We want to build on the knowledge that's out there. We want to advance the next generation relative to the previous one. So that's okay. In fact, what it does by giving students access to the internet is that you chop off that bottom level from Bloom's taxonomy. It's gone. You're forced to move up Bloom's taxonomy and test more meaningful things. That being said, I do not want my students to communicate, although we'll get back to that in just a second. So if during the individual part of the assessment they have, they start texting on their phones, or they have email or a chat messenger on their screen, that will be considered academic dishonesty. Okay, I'm going to jump here a little bit. I'm going to show you a little video clip taped at Bandung Institute of Technology in Indonesia, Java, just a little bit east of Jakarta. I want you to look at what these students are doing. It's in Malay, so you can't understand what they're saying. I want you to determine what the discipline is of this class, and secondly, what activity the students are engaged on. So first, the discipline. It's kind of unfair. You can't really tell. So let me just tell you. It's statistics. Have you ever seen students have fun in a statistics class? Well, there you have it. Next, what are they exactly doing there? Taking a test. Exactly. They're taking a test. Is that not a cognitive dissonance? I mean, taking a test on statistics and still having fun. I first came across this activity called readiness assurance, which is borrowed from team-based learning. If you're interested in team-based learning, go to teambasedlearning.org. At the University of Delaware, where I was Phi Beta Kappa Scholar a few years ago, as Phi Beta Kappa Scholar, you get to visit other campuses, 6 in a year, and you spend 3 days on each campus. You attend some classes, you teach a few classes, you give talks in different departments. It was a very nice opportunity for me to learn actually quite a bit. On my schedule when I was at the University of Delaware was a visit to a biochemistry class, junior level biochemistry class. As I went to the biochemistry building and I got to the room where that class was meeting, I saw inside 5 round tables, and the instructor was putting pieces of paper on the different tables. Each table had about 8 seats. And I approached the instructor and introduced myself, and he said, "Oh, today we have an exam." I thought, that's weird. Why would they have me visit a class when there's an exam? So I thought, there must have been a problem. So I said, I can go and check my email outside. He said, no, I want you to participate in the exam. I said to him, "What's the exam about?" He said, hemoglobin. I said, "I don't know anything about hemoglobin." But before I was able to protest, the students were coming in, and I had to sit at one of the tables. The exam was a multiple choice exam. I generally don't like multiple choice exam. It's possible to design good multiple choice questions, but I think many are not well designed. So I already was not in the best of moods. Plus, I don't know anything about hemoglobin. I looked at the questions. I couldn't really answer them very well. So we got the paper that had the questions with 4 choices each, and a little piece of paper on which to write our answers. 1, C, 2, A, and so on. After about 20 minutes, the instructor collected all those little strips. That was 50% of the credit. And on each table, he placed one of these cards called an immediate feedback assessment technique card, or if-at card. On the vertical, it has the number of the question, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. On the horizontal, A, B, C, D. There's only one card per table. And at the intersection, there's this paint that you scratch off, like on a lottery card. So the first thing the students at my table did was they appointed a scratcher, the person who was actually going to do the scratching. And then they said, well, 1 was an easy question. I had C. What did you have? C, C. Everybody had C. So they scratched off the C. There was a star, which means it's the correct answer. I still thought, okay, now we're making a game of these multiple choice questions. But then it became interesting, because we got to the second question. Half the table had A. The other half had B. The students who had B didn't want the A to be scratched off. The students who had A didn't want the B to be scratched off, because the team grade is the other 50%, and the team grade is what you get out of that card. So the A's were saying, don't you remember in the classroom, the professor said, all of a sudden they started to talk like scientists about hemoglobin. And then the B said, no, because when this happens, then that. Okay, let's scratch B. They scratch B, no star. Well, that's not a problem, because if you get it wrong, you can get a second try at half the credit. So they scratched off A, and they got 2 points. And if you get it wrong a third time, as in the fourth problem, you get 1 point. If it's still wrong after the third try, you get 0 point, but you know what the answer is. During the test, you have actually students give high fives when they get the right answer, and you have students go, oh, yes. You get the aha moments during the assessment. You get students gain insights, learn. By the time the test was over, 50 minutes later, and the students walk out, they were totally stress-free, they were happy, they had enjoyed it, and they knew their grades, and there was no grading. No grading. And this is easily scaled up. You can do it with hundreds of students if you need to do it. I did not adopt this because I don't like multiple choice questions. For many, many years I thought, how can I get away from multiple choice questions? Until I developed learning catalytics that allowed me to ask open-ended problems to the students. So this is a picture actually out of my classroom and out of a similar activity in my own classroom. And you see that the students have laptops in front of them. So you can ask questions like this question: what is the derivative of that function? This is from a math class. And the students can type in their response. They just type in an equation. And they would do that for 10 questions in a row. And then I press on a button, and the team round starts. During the team round, every student sees the answer of all of the team members on the screen. Brian answered 6x minus 6. Brent answered 6x. Kip, 6x squared minus 6. So they'll go, why did you answer this? Why did you answer that? They'll go to the board and work it out together. Let me show you a little video of this activity in my class. During the individual round, it looks like a regular exam, except that students have access to their computer and they can Google things as before. But it's individual and they're under time pressure. And then during the team round, it all of a sudden becomes much more animated. I make a habit of bringing in visitors during this part of the class and then asking them, what do you think the students are doing? And they all go, group work, and then when I tell them, no, they're actually taking an assessment, they go, what? How is that possible? How can you see smiles on people's faces when they're having an assessment? So the point from this first recommendation, Mimic Real Life, is let's not cut off students from each other. Let's turn the assessment into a learning opportunity. Let's not cut them off from information. Later in their life, they will have access to information. And if they don't know the amino acids and their work requires them to know the amino acids, they look it up quite a few times. But after you look it up quite a few times, it sticks by itself. It sticks because they need to know it. It's not sticking long enough to pass the test because somebody told them to remember it. I think it was Einstein who once said, education is what is left after all that is learned is forgotten. A very sad statement, but one actually that is very true. Second thing, let's focus on feedback, not on this ranking. Actually, I would argue the objective ranking is a myth. I know plenty of people, and you too, who dropped out of college and had stellar careers. And the opposite too, people who have stellar transcripts and end up disappointing. I'm on the graduate admissions committee. You know, you look at these records, you form a mental picture of who is coming in, and the reality is often totally different in both ways. Let me show you some data out of my own class. On the vertical, you see the final grade. This was before I changed my approach to teaching. On the horizontal scale, you see the result from applying an instrument that tests students' understanding of the concept of force. The force concept inventory might be used here as well, I don't know. But it basically measures how well students have understood Newton's laws, which are typically discussed very early on in the physics course. As you can see, the distribution is broad in both dimensions. There is some correlation, but not very much. But this is not really how we should interpret it. We should look at the following. According to the author of the test, anybody who scores below 23 has not understood Newton's laws. Is still partially an Aristotelian thinker, connecting force to velocity rather than force to acceleration. Actually, if you take a gorilla and you ask a gorilla to randomly press keys on the keyboard, you'd get a score of about 10 or 12. Notice that some Harvard students, score similarly to a gorilla. And notice that among the Aristotelian thinkers, there are students who have pretty high grades. There's a very broad grade distribution. At the other extreme are what you would get if you would ask faculty and graduate students to take the FCI. They would get 1 or 2 mistakes. So this is sort of scoring at the graduate level, and you see that a number of Harvard students actually get to score that high. I'm going to draw your attention to these 2 data points. On the left is a student who got an A in the course, but did not understand the concept of force. On the right is a student who scored at the graduate level, but got a C. Is this objectivity, or is it an injustice? So let's give up on this ranking. I don't think we're able to rank very well. I don't think we're able to predict the success of our students. Instead, we should really be focusing on the feedback and forget about those grades. Lastly, let's focus on skills, not content. I don't know how many of you are familiar with this book, Understanding by Design, by Grant Wiggins and Jay McTighe. In the traditional approach to curriculum planning, you start by determining the course content. In fact, most syllabi will say in this course we will cover topic A, topic B, topic C, topic D. And then you start covering that subject matter in class. And then after a few weeks or months or whatever, maybe you even wait till the end of the semester, you assess what the students have learned. In that case, the course is completely determined by the content. What Wiggins and McTighe advocate in this book, Understanding by Design, is something called backward design. Rather than thinking about the input, let's start thinking about the output. What is the desired outcome? What are the desired outcomes for this class? Ideally formulated in a way addressing the students. After taking this class, you will be able to, I find that many of my colleagues actually like this idea, but they struggle with the formulation of outcomes. And many will say, after teaching this class, you will be able to understand topic A, topic B, topic C. And then, of course, you're back to where you began. So what you need to have is you need to have action verb. After taking this class, you will be able to solve partial differential equations of this or that kind. Or after taking this class, you will be able to apply Newton's laws in this or that context. Or after taking this class, you will be able to interpret Renaissance paintings from Italy, whatever, things like that, action verbs. And in essence, you have to think about what you're going to accept as evidence that you've accomplished those learning outcomes. And then, only then do you think about what you're going to do in your class in order to maximize the output. But the key point, and this is the reason I'm mentioning this here, is that this forces you to think about assessment before you start planning what goes into your course. And often you get to much more authentic assessment than you would with ordinary curriculum planning. It's built in there, right in the middle. Lastly, and this is my final point, let's resolve this coach-judge conflict. What did I do for my project-based course? Well, in the end, the result was very simple. Let's appoint some external evaluators. I mean, that's what you would do in any other human endeavor, right? It's not the person who does the work who evaluates him or herself. So I asked some of my colleagues to come and evaluate the project. It has another benefit too. It validates what I do in my course with my colleagues, and they learn about what is happening in my course. Or, for example, one of the projects, just to give an impression, deals with musical instruments. Students have to build a musical instrument from recycled parts. So I asked a professor from the music department to come and judge, ideally someone who has somewhat of a background in physics. And that person, in the eyes of the students, is much more qualified to evaluate musical instruments than me, who is not a musician. The other thing is that we should make much more use of peer and self-assessment. And I want to emphasize that self-assessment because this is part of developing what psychologists call metacognitive skills, the ability to judge one's own learning. And, you know, in essence, I tell my students, look, when we give you your diploma at the end of 4 years, that's not when learning stops. That's when learning really starts. And we're not there to hold your hand and or to assess you. So developing an ability to regulate your own learning, to assess your own learning, is crucially important. Perhaps it's one of the most important skills that we have to teach our students. After all, nothing is worse than having people who are ignorant and unaware of it. One method of doing this is called calibrated peer review, a very unfortunate acronym, CPR. Do a Google search on that and you will not find calibrated peer review. This was developed at UCLA in the biochemistry department, and it's a way of, in a sense, crowdsourcing writing assignments. You give the students an assignment as well as a rubric. Here's one of the rubrics I have used for a writing. So you have categories and you have different levels of assessment. So students have this writing prompt and a rubric that tells them what the expectations are. They start writing their piece. After they've written their piece, they upload the piece to the calibrated peer review website. The URL is at the bottom left. Now, as the instructor, I have uploaded to the calibrated peer review site 3 calibration pieces. One that scores high on the rubric, one that scores average on the rubric, and one that scores low. And not only have I uploaded the pieces, I have also scored them on the rubric and explained my scoring. After the students have all uploaded their pieces, the next step, they have to pass a calibration phase. They have to rate the 3 calibration pieces according to the rubric. And they get a score that is determined by how close their scoring comes to my scoring. The closer it is, the higher the calibration score, which has 2 purposes. One is weighing their evaluation of their peers, and also weighing and also giving them points for the quality of their scoring. Then they get 3 random pieces out of the class anonymously of their peers, and they have to score each of those according to the rubric. So that gives a score for 3 peers, which are weighted with their calibration score. So if they score very similarly to the way I score, their scoring of their peers carries more weight than that of somebody who scores low in the calibration phase. By the way, they get several attempts to refine their scoring. So if they score really low in the calibration phase, they can do it a second time. If they continue to score low, they see the explanation of why I scored the way I was scored. So there's a possibility of even those who are poor scorers in the beginning to improve their scoring. Then after seeing those 6 pieces, the 3 calibration pieces and the 3 pieces from their peers, they get to reevaluate their own piece. Now all of a sudden they see their own work in the context of that of others, right? Normally you hand in your exam, you have no clue how your peers have done because you never get to see that. You are guaranteed to have seen a really, really good piece, the high calibration piece. You're guaranteed to have seen a really, really lousy piece. So you've seen a broad spectrum, and on top of that, you have seen 3 actual pieces from your peers. So the eventual score that is completely automated, there's no instructor who needs to do anything about this. There's the scoring from the peers, because there'll be 3 peers who have evaluated your piece, weighted with their calibration scores. And you get some, in order to tell students that it's not just the writing that is important, but also the scoring of others, they get a score for the quality of the self-assessment, for the quality of their peer assessment, and for their calibration score. And then finally, it coughs up a number. It's all completely automated. I know the great thing is, again, there is no grading to be done by the instructor. In a sense, everything is front-loaded because you have to supply these calibration pieces. Once you have it, it's done. It's done. And the students have learned much more than they would have learned in a traditional exam. Okay, well, my time here is up. So I'd like to end with a call to action. And the call to action is really very simple. We must rethink assessment. Because if we fail to do so, we will continue to educate the followers of yesterday instead of educating the leaders of tomorrow. And just as importantly, unless we rethink assessment, our test will continue to fail to indicate whether our students will be successful in their lives. Thank you very much for your attention.